Hi, everybody. Welcome to Ferncast webinar on immersive audio in radio. My name is Virginie Danker, Marketing Manager at Ferncast, and I will be your moderator today. I'm really pleased to welcome you. Today, we will dive into the fascinating world of immersive audio and into the Dolby Atmos experience with our guest speaker, Arnd Paulsen from Dolby Laboratories. We will learn how embracing immersive audio can modernize the radio listening experience. This webinar will last 1 hour, and there will be some time for questions at the end. But please feel free to use the chat to write your question during the webinar. You will also get a chance to win a Ferncast t-shirt with our traditional quiz, so stay tuned. And last information, I will send to all of you the webinar recording afterwards. Let me introduce now the speakers of the day. Detlef Wiese, Ferncast CEO, was supposed to be with us today, but unfortunately he is ill and he could not join today. But I'm really pleased to welcome two experts, Tobias Dornbusch, product expert at Ferncast, and Arnd Paulsen, Senior Manager, Broadcast and OTT Ecosystem at Dolby Laboratories. Thanks, Arnd, for being with us today. Let's have a look at the agenda now. Tobias Dornbusch will give us insights into the past, present, and future of immersive audio. Then Arnd Paulsen will showcase the Dolby Atmos experience in radio. And finally, Tobias Dornbusch will share some practical guidance on how configuring Dolby Technologies in aixtream software, including some demos. I'm going to leave the floor now to Tobias Dornbusch.
Yes, thank you very much, Virginie. And yes, I am Tobias, as we just heard. And first off, I will tell you a little bit about the history of immersive audio and 3D audio. Where do we come from in that regard? What developments were there? And how did we get to where we are right now? And what can we look forward to in the future? Right. So first, a little bit of a scientific and biological background, let's say. So, of course, the very first question is, why does 3D immersive audio even matter for us as humans? And the simple answer is that by, let's say, fortune of evolution, we have adapted to hearing immersively, which of course has all sorts of survival advantages, as you can imagine. And the way how this is realized in our bodies is simply the fact that we have two ears. Obviously, as you can imagine, if we had only one ear, immersive perception would not be possible in the same way. And you, of course, can very easily simulate this. If you hold one of your ears shut for a while, you will very quickly realize that your ability to locate noises accurately and so on will very quickly diminish or be basically non-existent. And on a somewhat higher level, how this is realized in our bodies is actually because of our amazing brains. So it's not, of course, an innate ability of our ears to process things like the location and volume as accurately as we do naturally. This is a lot of it is processed in our brain. And the way how our brain does this processing, or the basis on which our brain is processing this, is, of course, the slightly different inputs that each of our ears receives. So as you can imagine, for example, if a sound is coming from your left, then your left ear and your right ear will actually receive slightly different inputs. This means, for example, the left ear will hear the sound a bit louder than the right ear. The sound will arrive a little earlier on your left ear than on your right ear. Also, even the sound itself will be slightly different because of all the reflections from the environment and also the so-called sound shadow, from your head and so on. So you will even receive slightly different sounds there. Of course, you don't consciously perceive the difference, but our brains are capable of realizing the difference. And that is how, in our minds, things like the location of sounds is processed and realized. Yes, and with that, I would like to move on to looking at the technological developments a little bit. And of course, what the status quo is. So as you're probably aware, 3D and immersive audio isn't an entirely new technology. And in fact, it goes quite far back, perhaps farther than you might expect. But even if we're talking about modern things like surround sound, 5.1 setups and the like, none of this is like brand new technology. However, despite that, it hasn't properly spread in a lot of media consumption, especially in radio so far. Even now, much of the media we consume, whether that is TV or radio, is still in mono or stereo, despite all the technology being there. Now, for you as radio broadcasters, this of course means that having your content available in 3D and immersive formats could be a major competitive advantage. The simple reason there is that for us as humans, immersive and 3D audio is simply a much more natural way to experience audio, as we have seen a moment ago. So giving this experience to your listeners will make your listeners appreciate your audio content more, enjoy it more, and thus, of course, it is a competitive advantage to have. Yeah, as I mentioned, the history goes back actually surprisingly far. As we can see on this slide here, Harvey Fletcher already in 1925 filed a patent for a binaural telephone system, as he called it. And as you can see at the in the image, the diagram at the bottom there, the concept was quite simple, but this is actually this is an idea that many later technologies built on. So you simply had two rooms that were connected by two separate audio transmission lines, effectively. And in one room, you had the microphones, which were placed on like a sort of imitation of a human head. This was important, of course, to cover things like the reflection and the sound shadow, etc. And of course, in the other room, you then had a person with a headset on. And each channel from the first room goes down one audio transmission line to exactly that earpiece on the other, so that the exact way how the audio was basically recorded or taken in the first room was transmitted to the second room. And we're going to see a few more examples how that idea evolved later. One quick thing I wanted to point out, Mr. Fletcher actually even received a posthumous Grammy Award in 2016, so not so long ago. So this is a good example how long ideas can sort of simmer before they are truly appreciated or further developed. As you can see on this slide here, this is a very short, succinct summary of further developments in this field. So, of course, in the 60s, we had the first proper stereo radios, though even that was already, at least to a degree developed in the 30s, then 60s, 70s, quadrophony, what we would call like maybe 4.0 nowadays, was tested and developed. Dummy head recordings came later. This is also something interesting we're going to see pictures of in a moment. And this is sort of a evolution of the idea of Mr. Fletcher. Shoulder speakers go also in a bit of a similar direction. And then, of course, we come to things like Dolby Surround and similar developments. Here's the timeline with pictures. So, of course, we've already taken a look at the patent diagram from Harvey Fletcher. In the second image there in the 70s, 80s, you see sort of these artificial heads, again, with microphones built in to, once again, more naturally record the sound for recording, and then, of course, the transmission or playback. Next to that, this is actually an example of the shoulder speakers that we mentioned on the last slide. I've been told they were actually very heavy and probably not particularly well suited for mass production or mass enjoyment, really. But they were, to my knowledge, actual like shows in cinemas where these were used. But again, because of the sheer weight, they probably weren't particularly nice to have. But of course, as you can see there, they had large speakers with a surround effect. And of course, since they were effectively binaural, you had a very good surround effect there. Then we had the Dolby Surround and so on. Right, and nowadays, I already mentioned some of these considerations in the beginning. So, of course, we have the big five, with which we mean, of course, companies like Google, Amazon, Apple, Meta, and Microsoft. Many of these, as you're probably aware, either develop or have developed conferencing systems, meeting software, those sorts of things, or even kinds of playback and recording softwares and so on. And like Zoom is one of these as well, of course, although not from one of these big five. And naturally, as you can imagine, a lot of these meeting softwares, they're either mono or stereo, of course, but surround sound would be very pleasant in a lot of cases, especially if you imagine like the classic sort of scenario where you have an actual meeting room that is connected via speakers and microphone to other participants online and so on. And yeah, as I also mentioned, streaming services can definitely benefit in the entertainment sphere and so on, including also, of course, various consumer and pro products that want to get really the most out of their audio. This is basically what we already talked about. Here are also the logos of the big five. But obviously, as I also mentioned, they're not the only ones working on more products in this space that take advantage of immersive audio. And last but not least, of course, we want to also mention how we are involved in this topic, although, of course, there's going to be a bit more on this towards the end of the webinar. So we actually started cooperating with Dolby fairly recently, because existing customers of ours requested at first for our encoders that they use to handle the packaging of Dolby Atmos audio. And in fact, the end product of this endeavor was this particular podcast that you can see here, the $1 Billion Apes, produced by the Deutschlandradio and ZDF in Germany, which was basically a longer podcast series. And as I mentioned, the audio was packaged in our encoders by us. This is how we started. Nowadays, we actually also support the encoding and upmixing of the new Dolby formats, but a bit more on that later.
Thanks for this insightful introduction on immersive audio. It's my pleasure now to leave the floor to our special guest, Arnd Paulsen from Dolby Laboratories, who is going now to showcase the Dolby Atmos experience in radio. Arnd, the floor is yours.
Thank you very much. Also, welcome here from my side. I'm really glad to work with you and talk about our technologies which we have developed. And today this is about Dolby Atmos, in particular Dolby Atmos in radio. To myself, I'm working here at Dolby in Nuremberg. I'm looking after all the broadcasters and radio stations, TV stations, telco companies, and yeah, I help them in consulting them to adopt Dolby Technologies, new Dolby Technologies, ideally. A bit of our history. Yes, we started pretty early with Ray Dolby himself, developing noise reduction. He started his company in the 60s. Apart from solving industry problems like noise reduction, we also learned that experience really matters. We developed Dolby Stereo in the 70s with Star Wars, with Batman. We went digital, having actual surround sound, achieved many award-winning, movies in very close cooperation with the movie makers. And nowadays we see ourselves as an experience company. We have a video experience that's called Dolby Vision, HDR, high dynamic range, and our immersive audio experience, which is called Dolby Atmos. That's a bit of a teaser. Wherever you come from, if you're a broadcaster, a radio station, or a content producer, do you still produce in stereo? Or you already stepped up to 5.1 maybe, or even Dolby Atmos sound? And this is what it is. So stereo, we all know from the Walkman times, from FM radio, you have two speakers, you have two ears, left is left, right is right, and that's basically it. Yes, you can do some what we call binarization, you get a little bit more out of it, but if you treat stereo as stereo, then you have a pretty boring experience. Later, we thought, oh, okay, let's do sounds from behind and more clearly from what we call a center speaker. And that really took off cinema, I would say. So Dolby Surround is still a flat experience. So it's all in one plane, as we say. You have a synonymous name is 5.1. You have 3 speakers in the front, 2 in the rear, maybe a subwoofer, that's the .1. But it's a flat experience. So it's not really what nature shows us or what we experience in nature every day. And there, Dolby Atmos came into place, which is a true 3D sound experience where we also have sounds from above. And you might think, oh, how can I, make this real? How can I experience this? I hope I can answer all those questions, and you hopefully are surprised in how many environments you can experience Dolby Atmos and in how many scenarios already today. You might have different names for this. You might have heard immersive audio, 3D audio, or even spatial audio. So there are many terms which are floating around. When it comes to Dolby, we call this the Dolby Atmos experience, and this means all of those, immersive, 3D, or spatial. There's 2 ways to produce Dolby Atmos content. And if you're a content producer, you might have done this already in post-production. So you have something, what we call audio beds. This is sound as of today. It's channel-based. It is like 5.1. You may have heard 7.1. It's something which directly relates to speakers. You put some voice or sound or wind in the left speaker and it will come out of the left speaker at home. So these are audio beds. You can have very diffuse textures, as I mentioned, wind or the sound of the sea, very classical. The clue now is objects, audio objects. What we add to the beds are, I call them flying objects. So this could be a bird, could be a helicopter. So it's a mono sound which has metadata assigned, positional data, for example. So you tell this bird is in the left corner above. And then you will hear this in the left corner above. And also you can make this fly. So this metadata, this positional data, can actually be timecode based and you can move objects around. And this creates really the Dolby Atmos experience, which gives a lot of flexibility to the creative person, designing such a sound for a movie, sound for a podcast, even sound for a music clip. And what's really good about this object-based audio is it renders on any speaker set. It's no longer tied to channels, like a stereo setup, a 5.1 setup, 7.1 setup, or even beyond in cinema, where we have 30, 60, 100 speakers. So this object audio renders on all speaker environments. So a lot of flexibility and a lot of creativity. Audio objects. So it's something you should remember. An audio object is a sense. So that's the mono track of a sound of a helicopter, of a bird. And there is metadata added. So this metadata describes this audio object, the position, its size, the diffusion. And by making these objects or these metadata even counting up, like the height or the left or the right, you can also move things around in curves or in straight lines. There are tools for this where you have objects, you can switch objects on and off, you can have objects flying, you can assign a curve to it, then the object's automatically flying within the time of 5 seconds from the bottom left over to the middle in the high and to the right in the bottom again, like a helicopter flight, for example. And we call this OBI, Object-Based Immersive. And this is something for the post-production, because you have a lot of time, you can listen to the objects, combine another object, maybe 100 objects, and make really complex sound scenes with this. This works. This is the way people work in post-production. Now there's also live Dolby Atmos. We know from football games, maybe from concerts. This is recorded with microphones. As of today, as you would do today, you don't do it in post-production. You do it maybe in an OB van, in a production suite, but the sources are actually microphones. And those microphones hit a mixing desk where somebody sits in front and, moves the faders, makes every microphone louder, positions the microphone wherever it should go, and hopefully creates a good ambient atmosphere, like the sound of a concert hall, for example, or a football stadium. So stuff is on the mixing desk. All beds or stems are on the mixing desk, and they can be locally rendered. So the operator or the mixer can actually listen to what he does in a 5.1.4 environment. So we call this no longer 5.1. We call it 5.1.4. It means we added 4 height channels. We don't use we use all the 20, 30 microphones, but obviously we mix something that's shorter. You can, for a football game, for example, you can add commentators. And with the beauty of new transmission systems, you can also kindly object-based separate the atmosphere, like the 5.1 bed of a football stadium, and then multiple commentators, maybe an English commentator, a German commentator, or a blind commentator. And this can all be put in the contribution and sent over to the home where the user can choose. I like a commentator or not. I like the German, French, English commentator. I can switch one on. Or I have accessibility issues. I can switch to a blind commentator, or maybe even a children's commentary or director's commentary. So this all, can be pretty much done in live. And the term for this is CBI. It's channel-based immersive. It's like producing stereo. It's like producing 5.1. You add 4 height channels and it becomes immersive experience, which is channel-based. So no flying objects. Maybe that's the opposite to object-based audio. We call this CM, complete main, when it contains already the commentator. So it's a ready-to-use mix, complete main, 5.1.4, everything in it. or optionally M&E plus D, that means music and effects. That's separate, that's only the atmosphere. And then you add a dialogue to it, or multiple, one language, two language accessibility tracks. And we call this M&E plus D, music and effects plus dialogues. So now a bit techie stuff. Where we come from as Dolby, from audio codecs, we see ourselves now more as an experience company, but nevertheless, we need to transport things to the home, to the user, and we use audio codecs for that. And some of you know those codecs here on the left side, which translate into an experience on the right side. So to the consumer, we just communicate experiences. The consumer should not know which technical codec has been used in the background. These codecs have technical names. Most of them can do the same thing, and consumers shouldn't know about it. They just should see the brand and the experience, so they know what they can get. So for example, to deliver a stereo experience, I can use any audio codec, obviously. I can use the good old Dolby Digital, the Digital Plus, and our latest codec, which is called Dolby AC4. Doesn't have a marketing name anymore because the user should never see it. Yeah, basically that's fundamental. Every stereo codec you find out there can deliver a stereo experience. A 5.1 experience, yes, all those Dolby codecs, can do this. The good old Dolby Digital, Digital Plus, even AC4 obviously can deliver a 5.1 surround experience. So nothing really spectacular. But when it comes to Atmos, AC3 cannot be used for Atmos. Even EAC3, naturally, in the channel-based way, cannot deliver an Atmos experience. We extended EAC3, the Dolby Digital Plus, which an extension we call GOC, Joint Object Coding. And with this extension to the existing codec, we can deliver a Dolby Atmos experience, either object-based or even channel-based. And our new codec, the AC4, it can do even more things. At a lower bit rate, I can carry around multiple commentators, which are mixed in the receiver by user choice, by setting balance values. Maybe I want the commentator louder, I don't want a commentator at all. So you have a personalized experience. We call that personalization, audio personalization, where you can at home modify the audio. That's only possible with Dolby AC4. I want you to know that a codec, an audio codec, is something different than the audio experience. That's something you should take home. And just to remember the codecs that deliver a Dolby Atmos experience. So there's AC4 CBI for channel-based audio, live audio. There's AC4 Immersive, which is meant for mobile phones, very, very bitrate efficient audio codec. There's the good old EAC3 JOG, Dolby Digital Plus, JOG, which is on Blu-ray, for example, but also in broadcasting. And there are other ones which you might have encountered or not. There's Dolby True HD, which is also on Blu-ray, Dolby Mat 2.0 for in-home carriage on the HDMI cable. So all these technical terms, consumers should never see, but you as a professional might run into those. Now at the home, I want you to understand the difference between a decoder and a renderer, because in the past we just had decoders. There's a 5.1 decoder, you get a 5.1 in, you produce loudspeaker signals for 5.1, fairly simple. Nowadays we have, behind the decoder there's a renderer, and the renderer projects the incoming audio after decoding. The renderer projects it to the loudspeakers and to the loudspeaker layout the consumer has. So you might think of a cinema, for example, which has 30 or hundreds of speakers. So the renderer gets those audio objects in and puts every object in the right position. And as objects could fly, yeah, this is a linear transition of the object from speaker to speaker to speaker. And the more speakers you have, obviously, the smoother the sound is moving. So one way to experience Dolby Atmos, obviously, is in the cinema. And that's where we started. And yeah, once we, excited someone in the cinema, we want obviously that they take this experience home. And yeah, you can do this with home cinema systems. Those sometimes weigh 30 or 20 kilos, an amplifier. And then you have 5, 6, 7, 10 loudspeakers connected. Some even put loudspeakers, in the ceiling to get the above sound. Now, that's not really practical. We invented something which we call the Dolby enabled speakers. That's an up-firing speaker. And this shoots at the ceiling, reflects there, and the sound magically comes from above. So you can create a Dolby Atmos experience even in the home. You have 4 of those, and this creates a lovely, nice sphere, around you and above your sofa. And this should feel like being in the cinema. Now, this is something not everybody wants to afford or can afford in his living room due to, you have to have cabling there and, of course, space. And you have to maintain the speaker layout. The speakers must be where they're supposed to be. That's the constraint of a channel-based system. So we came up with easier devices like soundbars, for example. You put them in front of your TV, could be 1 meter long, 1 meter wide, shoots up in the air, shoots to the left, to the right, to the front. And this actually also creates a very nice Dolby Atmos experience with one device, one HDMI cable connected to your television. And yeah, no hassle with speakers and cables. For those that think that is still too complicated, we even came up with Dolby Atmos televisions. So this is something like you buy in the hi-fis or in the electronic market, just unpack it, put it on your desk, on your shelf, and playback Dolby Atmos. So everything is integrated. They have also loudspeakers firing to the table, firing maybe to the left, even firing upwards. And with a Dolby Atmos TV, you can have an Atmos experience right out of the box. No hassle, works as it goes. So most people might not even know they have a Dolby Atmos television. They just bought one. They're not expensive, maybe start from 300, 400 euros. And so the number of Dolby Atmos homes is really incredible. The next thing that's going to launch at ANGA.com here in Cologne is an operator box. So this is what we call ISS, Integrated Operator Set-Top Box Soundbar. So this is a set-top box you get from your cable provider, from your telco, where you can play back, television services. What's new about this set-top box now features speakers. So for example, this one has a left speaker, a right speaker, a center speaker, a subwoofer in the middle. It's 14 by 14 centimeters square, and provides a great Dolby Atmos experience for those who don't want to have a soundbar or want to install speakers. So very new invention. But there's more ways to experience Dolby Atmos. We as mentioned already, mobile phones, our famous Deutschlandfunk ZDF production. You load this app onto your smartphone or tablet, choose some Dolby Atmos content, which is indicated with the Dolby Atmos logo. Listen to Atmos on your speakers. Yes, we render Dolby Atmos sound on 2 stereo speakers. You should try it. It's kind of jaw-dropping, as the Americans say. You hear sound from behind without there being actually physical speakers. Also, with headphones, this works quite well. It's this binauralization, which we have seen in the early patents from Harvey Fletcher. So we turn the object into a binaural rendering, and then you hear it as if you're in the scene. And last but not least, we're also innovating. The next target we have is the automobile, because automobile is a perfect location. The driver is at a constant position. We can render sounds, particularly, for the ears where we know where they are. And also the car is a good way to experience music, a full album. You sit in a traffic jam or on the Autobahn, you have time to listen to a complete album. And yeah, we want this experience also to be in Dolby Atmos. And yep, if you are a Mercedes-Benz driver, you can opt in for that. So with Mercedes-Benz, we already have Dolby Atmos cars on the road. Looking for more content, if you are a content producer or content creator, broadcaster, what you experience now is obviously Dolby Atmos music, but I can see also podcasts going into the car, maybe documentaries, eventually audio, video content, movies, if that is permitted, in the street or while standing, while parking, while charging your car. So there's a lot of opportunities for audio content in the cars. And this should, conclude my presentation for Dolby Atmos audio, immersive audio. Thank you very much.
Thanks, Arnd, for sharing your expertise with us. I don't know if you have any questions. Please feel free to use the chat to write your question. I don't see any at the time, for the time being, but we will have time at the end for a Q&A session with Arnd. But you can always write your question in the chat. Now it's time for our quiz. So I hope you listen very well to Arnd's presentation, because we have questions on it. So today the question honestly is easy compared to last time. So you have to be fast. You have to be fast, because the fastest one will win the Ferncast Polo. And in fact, there is 2 questions. So we are expecting the two answers, 2 right answers at the same time. So here are the questions. What do CBI and OBI mean? So please use the chat, put your answer to everybody, not only to me, and we will see at the end who is going to win. Now we will continue our webinar. I will leave the floor to Tobias Dornbusch, who is going to show us how to integrate the Dolby Technologies in Extreme software. So we'll get some practical guidance, including demos. Tobias, the floor is yours.
Thank you again, Virginie. So I'm quickly switching over the screen sharing here, and you should see my screen now. Right. Very quickly, because before we get to the Dolby specific stuff, I just wanted to give those of you who may not be so familiar with Ferncast and Extreme yet, just a very basic crash course on what we're even doing, so you have a little bit of context there. So, of course, we are an audio logistics company, as we like to call it, and thus our main product, of course, is an audio logistics solution, specifically a software called Extreme, which can be installed on just about any kind of hardware, and with which you can do the encoding and transport of just about any kind of audio, almost entirely independent of what kind of input you're using and what kind of output you want to generate. And the way how we realize this on the workflow level, on the configuration end, is via the so-called pipe concept. So the idea behind the pipe concept is that the entire audio workflow, everything that happens with the signal in the system, is displayed as this, we call it elements, this row of elements. That's these colorful circles that you see here. So as a simple example here at the top with this VP to stream example, we have a regular audio interface connected. So this could be like an analog XLR or maybe a MADI interface, something like this, channels coming in. In this case, the volume control is enabled, level is being measured, then the signal is encoded in MP3 and goes out as an icecast stream in this example. So for a web radio, for instance. And by the same or in the same pattern, you can configure just about any kind of audio setup, as I mentioned. So you can also have like even like DAB inputs where we're taking signals from the air via, of course, DAB reception hardware and so on. That's all possible. Now, getting specifically to the Dolby example, we have prepared a few pipes or specifically pipe groups to show you here the different options you have and also how to make these work. A very quick word on our groups. So pipe groups are simply, or in the first layer, pipe groups are simply a way how to control multiple pipes, multiple input outputs at the same time. But you can also use these for more advanced functions. Specifically, as you can see here, this is about HLS streams in this example. This is also, the pipe groups are also used to configure like adaptive bit rates, different formats and the like. And of course, this is quite interesting if we're talking about Dolby encoding, Dolby options, etc. As we can see here, for example, at the top, this group called Webinar Demo. In both cases, we use files that have been prepared, including with the JOC. Encode these, of course, and send these out as HLS streams. As you can see, there's only a single upload configured here because they go out as an adaptive stream, which means that the listener on their end, obviously assuming the app or the web platform that they use supports this, will have an option to choose between the two encoding formats here. So we have one as a simple stereo AAC, but it has been processed in such a way to, as Arnd mentioned, they have means and ways to sort of quote unquote fake the Atmos effect, the surround effect. But for those players, for those end devices that actually do support genuine Atmos, we of course have this stream. And as I said, they go out together. They would be available under the same URL. And there, accordingly, you could, or the end listener could then make the choice. Just to quickly show you this on the configuration level. So, of course, once you have configured a pipe, you can simply click on an element and then do the configuration there, make your choices. For instance, what kind of format you want to use as a file multiplexer, just as one example. And of course, since it's going to be a web stream, setting up kind of where the playback URL is supposed to be, and so on and so on. Of course, also playlist-specific things, if you're familiar with HLS, the segmenting and so on, all of these things could then be configured here. Right. But as we mentioned before, we also support a few other options. One very interesting thing is that we also do upmixing. This means we have a signal that has a lower channel count that we then use the Dolby renderer for to, well, simulate might not be exactly the right word, but of course upmix it to a Atmos output to, yeah, simulate Atmos experience there. And what is very interesting with these streams that you see configured here right now, these are actually online via our own HLS server. And in a moment, you will actually get links from us where to find these so that after the webinar, you can actually take a listen, I should say, so that you can, for one thing, of course, just hear the Atmos in person and, of course, also compare the different streams. That is, of course, why we set up the different variants here. One more interesting thing just for the future. Currently, we don't support this yet, but this is something we're looking into, is to actually support processing the positioning. As, of course, Arnd explained, this is also an important aspect of Atmos. via metadata input. So metadata is also something we can process in various ways, and this would be also a next step for us to support this via the metadata input. So we don't need a pre-processed object positioning. Right. This was just a very quick look at this. Of course, if you have more interest in Xstream in general or this specifically, do contact us. There will, of course, be also an email address at the end, and then we can take a much deeper and more specific look at these functions. But for now, I would hand over back to Virginie.
Thanks, Tobias. I was looking in the chat, so we got a winner already for the quiz. Thomas Fungel gave us the right answer, and he was the fastest one. Congratulations, Thomas. So you won a Ferncast Polo and a Ferncast cap. So the answer were in the presentation of Arnd. So CBI means channel-based immersive, and OBI, object-based immersive. And so now this webinar is coming to the end, but before we leave, we would like you to experience the immersive audio. The experience is quite amazing, I would say. Would love to listen to radios with the Dolby Atmos experience. Great. So I don't know if we have in the chat more questions. We still have.
Yes, I'm Cedric here. I have a question.
Mm-hmm.
What about radio?
Yes. So as I mentioned, of course, it's very interesting for sports transmission. As you saw, we can, of course, support this for HLS streaming, which is, of course, also available for just general web streaming. So this way, of course, you can also make it available to radio listeners.
But then without any Atmos content, it's just stereo or binaural, right?
Well, that depends. Of course, we have this simulated Atmos via the stereo AAC, which as long as you have any sort of headset, you can experience, or the listener can experience. And if you have, for instance, your own smartphone app, or you somehow get your listeners to use something like the Bit Movement player, this is an example, then of course you can support actual Dolby Atmos in those apps. Like here in Germany, at least, a lot of the broadcasters have their own smartphone apps for their radio. And then, like for instance, Deutschlandradio, as we said earlier, do actually support Dolby Atmos in those apps for the full experience. And then, of course, via Xstream, for example, you could stream it as web radio, and then your listeners can receive that.
Okay, so it's all only web radio. We're not talking about normal DAB broadcasting, right? It's always
in this, at least in this case, we're talking about the web radio. Yeah.
All right. Okay, we get it. Mm-hmm. Thank you.
So there is a question about AC4 IMS I'd like to answer.
Mm-hmm.
So Dolby AC4 IMS is targeted for mobile phones, particularly Android phones, and it has a stereo core enhanced by metadata. So with a stereo core plus the metadata, we can create an immersive experience. And there's also a question about YouTube. What we do is we transmit this IMS stream, and then we render it in the device. So we can render this to the built-in speakers. I put my tablet or mobile phone in front of me and get a lot wider sound, even sound from behind. I can plug in a headphone. I get a binaural version. Or I can switch off Atmos, get stereo, maybe to feed it on to a Bluetooth speaker or in the car. So from one bit stream, we can generate 3 experiences. And you can't do this with pre-binauralized audio. So if you have a pre-encoded binaural stream, like they have on web portals, YouTube, for example, you must listen to it on a headphone. you can't play back on speakers, or you can't switch off this binaural effect because it's already in the stereo. So that's a major difference of a codec, which is particularly made for an immersive experience.
Thank you.
There's a VLC player question. No, VLC player has some open source decoders in it. They're not originally from us, from Dolby, so there's no quality assurance on these. It's known they don't treat the metadata as accurate, or even as we do, or even ignore metadata. So you won't get a Dolby experience with a VLC player.
If you like more infos, anyway, you can always contact Tobias, or if you like a personalized demo or more information on web radio, please contact Tobias. If we don't have more, yeah.
Yes, I have a question about Atmos. So can I get, if I have an Atmos, I don't know, receiver or like or something like that in my TV, can I use binaural audio? Like, can I get the binaural version of Atmos, like listening to with headphones with my TV?
Whatever receiver you have, you must connect headphones for binaural audio stream. And then it depends on the receiver if it correctly reproduces or passes through this binaural stream. I would doubt it works. Let's say, first of all, you must have a headphone output on your television, and then you must play back the stereo as untouched as possible. That's why, as a broadcaster, you must distribute several streams. You must distribute a classical stereo stream, then you must distribute a binaural stream. You may distribute a stream with accessibility inside, which has clearer speech. You might have a stream for the blind, which has audio description. So you're damned to produce a lot of streams and distribute a lot of streams for different experiences. And with a modern codec, you can do all this in one. And let the user choose. So as a broadcaster, you don't have to know how your stream is currently played back. That's decided in the playback device.
I would like to thank you, Arnd, for your participation today to our Ferncast webinar. I would like also to thank everybody for your time and your participation. I wish you all a good day, and see you next time in our next Ferncast webinar. Goodbye. Thanks for your time.
Thank you.
Bye-bye.
Goodbye, everyone.
Thanks for
Thank
your
you. Goodbye, everyone.